Hey folks, this is Manu from Steadybit. Today I want to talk about randomness in chaos engineering experiments. Randomness is a pretty important concept in our chaos engineering experiments as it prevents us from overfitting our reliability tests. Instead of proving that one specific deployment or one specific AWS zone can fail, we want to continuously verify that any deployment or any zone can fail without impacting the system. And today we are making a huge step forward to give you more control and advanced randomness when designing your chaos engineering experiments. Let me jump into a specific example by going into the Explorer to understand how my system looks like. You can see we're talking about a small Kubernetes cluster with a few Kubernetes deployments. Some of them have multiple pods running per deployment, some of them don't. Some are running in different availability zones, and some are running in the same zone. Now let's assume I want to delete all pods of a random deployment. For that, I would configure an experiment like this, using the delete pod attack, choosing the namespace, and then use a random blast radius of 1. Now in this case, we would pick one arbitrary pod, but as we saw earlier, there might be 2 pods per deployment, and this way the deployment still has one running pod. And this is not really fitting our scenario. Instead, I can go for the advanced blast radius, where I can first group based on an attribute, like group on the Kubernetes deployment, and then pick one arbitrary deployment to delete all pods in there. And now it would affect one pod if it chooses notification deployment, or 2 pods if it goes for the gateway or hotdeals deployment. Now the challenge with that approach is that you can't know in a subsequent step which specific deployment was picked. That's a problem we are fixing today by introducing dynamic values for variables and allowing you the full flexibility across your experiment. Now I have slightly changed my experiment, and now I'm using an experiment variable which defines the Kubernetes deployment. But instead of using a fixed value, I have configured a dynamic value. And this is looking at the Kubernetes pods deployment attribute and randomly selects one specific Kubernetes deployment value. It could be a gateway, an inventory, or a notification deployment. This variable will be evaluated when I'm running the experiment, and I can now reference this variable across my experiment design, like in here where I delete all pods of a random deployment, and also in a subsequent step where I want to check how long it takes until the specific deployment has all pods running again, or even in a Prometheus matrix check where I want to see the Prometheus matrix. Now, when running this experiment, you can see the used variables at the top, and in this case, it picked the hotdeals deployment. And this way, it will delete all pods of hotdeals, checks the startup time of hotdeals, and shows the matrix of the hotdeals deployment from Prometheus as well. And of course, when running this experiment again, it will pick another one, like in this case, fashion bestseller, and adjust the experiment as needed. Because we're talking about variables, you can use this dynamic value wherever you can define a variable, like in the experiment variable, in the outer scope, in an environment, or an experiment run overrides per schedule, or whenever you run the experiment right away, to really have the full flexibility. However, we haven't stopped here with variables. Services now also support variables, and you can use the dynamic value approach as well, and for instance, choose on a service level that a random zone or a random region should be picked. Of course, you can also reference one with the other, like in the zone, where the dynamic value is referencing the picked region and then evaluates the matching zones. Now, this becomes really handy when thinking about provided experiments, because in here, the service variables will be automatically resolved. Let me look at the example of this experiment template here that is providing this experiment, where we are referencing not only the service, but also the 2 variables region and zone. If your environment or your service is defining those, you can easily instantiate this experiment template as a provided experiment with a single button click. It automatically evaluates the region and the zone, in this case coming from the service variable, and use them for evaluating your targets with the configured randomness. Like in here, it's the Eurocentral 1A, and now it might be the Eurocentral 1B whenever I'm starting to run this experiment. As always, you can see the used variables in the experiment run to make it really easy to understand what was attacked. Of course, we have full support for dynamic variable values in the API as well, like here in the example of an environment variable, where I specified earlier the Kubernetes cluster name to be a dynamic variable value. If you want to learn more on service variables, check out the service as well as the experiment variables documentation explaining the differences between fixed and dynamic variable values in more detail. Thanks for watching and take care.